Hi, and welcome to chemistry again. All right, so today we're going to talk about double and triple bonds. We've already talked about single bonds. If you need to, go back and watch that video. But we're going to start by having a look at oxygen. So in your notes, we're on the page that starts with double covalent bonds. Now, we're going to think about an oxygen atom. Now, an oxygen atom has got an electron configuration of 2, 6. Okay, so that's one oxygen atom. So how many electrons does it need? It needs 2 electrons to give it a stable octet. So that's our first line. The oxygen atom, electron configuration 2, 6, needs another 2 electrons to attain the stable octet configuration. Now, oxygen, the gas that's in air, is O2. Now, why is it O2? How can this work? If they share one each, they're only going to have 7 in their outer shell. So let's just see what I mean by that. So if you had 2 oxygen atoms, I'm only drawing their outer shells. We know that we're covalent. So we go 1, 2, 3, 4, 5, 6. I'm just going to use another colour for this one. 1, 2, 3, 4, 5, 6. Can you see how these guys are all floating around on their own out here? That's not really going to work. And if we double checked ourselves to see if we've got an octet, let's have a look. 1, 2, 3, 4, 5, 6, 7. Now, that's not an octet, so that's not going to work for what we're talking about. So what we do instead is each oxygen atom can actually share 2. 1, 2, 3, 4, 5, 6. Okay, now I'm going to put these 2 together in a second just to show us that they should be closer to each other. 1, 2, down here. So now we're going to try and share 2. So we do our other oxygen atom over here. It's got 1, 2, 3, 4, 5, 6. Let's check our octet. 1, 2, 3, 4, 5, 6, 7, 8. Yay! Check the other octet. 1, 2, 3, 4, 5, 6, 7, 8. Yay! So they've both got a full octet now, and they did that by sharing 2 electrons. So looking at our notes again, it says each oxygen atom can gain these 2 electrons by sharing 2 with the other oxygen atom. When oxygen atoms approach each other, 2 pairs of electrons are drawn into the region between the 2 nuclei, and the outer shells partially merge. The result here is what we call a double bond. Now, a double bond is 4 electrons shared. A single bond is 2 electrons shared. Double bond is 4 electrons shared. Now, what do you think that means if you're going to share 4 electrons? If you're going to share 4 electrons, you're probably going to end up with a much stronger bond, and also they're going to be way more connected. So think about 2 shared like this. Yeah, the moment you bring in that second finger, look at how much closer I can get. So I'm going to take away my pencil and show you again. So 1, you can see the bond length there is about the width of my eyes. If I do 2, can you see how my bond becomes much shorter? Okay, so if they're sharing 2 electrons, that bond is going to be much shorter. There we go. That's what it looks like. This one's got its inner shells on it as well. So let's just fill in our booklet, make sure we're okay with this. How many outer shell electrons in oxygen? We have 6. How many bonds does oxygen need then? 2. How many lone pairs, when we draw this diagram, does each oxygen have? 1, 2. And how many bonding electrons exist? We have 4. And after bonding, do all atoms have a full outer shell? Yay, excellent. So let's have a look at a bit more of a difficult example. This one is ethene. Now, we did ethane in class the other day, and it's C2H4. So we know that carbon has 4 valence electrons. We know that hydrogen has 1 valence electron. So the carbon itself can share some electrons. There we go. This is normal carbon. Let's just get another color because it's much easier. Okay, so that's a carbon with 2 carbons with a single bond, and we have 3 spare electrons on the outside of each one. Now, if we want to add in hydrogens, we could add in, how many hydrogens have I got? 4. 1, 2, 3, 4. Okay, now each one of those hydrogens, this is really not to scale, can share 1. But what do you notice is happening out here? Can you see how those 2 electrons there don't give us our stable octet? Let's just check. 1, 2, 3, 4, 5, 6, 7. Yeah, there's not enough electrons there to consider it a stable octet. So what we need to do is we need to get rid of this electron over here, and it's also going to be shared in the middle. Now, we can't form a bond unless both of them are giving in. So let's put this one over here. So what we end up with is something that looks a bit like this. Now, there is another way of drawing this to make it a bit simpler. So this is what we call an electron dot diagram, and I'm going to go through the other one. But we can show our double bond like this. Much easier. Single bonds are with a single line, and double bonds are with a double line. Let's just make sure we've got our booklet finished here. So how many electrons in the outer shell of carbon? They each have 4, so they need 4 bonds. How many electrons in the outer shell of hydrogen? And they each need 1 bond. When you bond them like this, we have a full outer shell? Yes. What do you notice about this and lone pairs? Yeah, I would say it's really obvious that there are no lone pairs in this molecule. Okay, and that's going to come into play when we talk about the shape of molecules in a minute. So here's a bit of a challenge. I want you to pause, see if you can draw it, and then come back in. All right, so let's think about this. Carbon has 4, oxygen needs 2. Okay, so carbon has 4, it needs 4. What it's going to do is it's going to share 2 over here, it's going to share 2 over here. Now the oxygen is going to share 2 because you have to make sure that we're all equal, so each oxygen is going to share 2. Yeah, we've got 1, 2, 3, 4. So the red ones for the oxygen, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And what we end up with is something that looks a bit like this, or if I draw it, it's O double bonded to a C, double bonded to an O. So carbon dioxide, actually a very stable compound. It's nice and balanced. Are there any lone pairs on the carbon? No lone pairs on the carbon. And each one of the oxygen, how many lone pairs does it have? 2. Yay. So there's pretty much only ever one real example that we talk about with triple bonds. So we're just going to go through this little bit in your notes. It says triple covalent bonds. And then underneath it says nitrogen atoms. The electron configuration of a nitrogen atom, just one, okay, is going to be 2, 5. Okay? So they can each bond with each other to form a triple bond, because how many electrons are in the outer shell of nitrogen? We have 5. How many bonds does it need? It needs 3. So if you get 2 nitrogens next to each other that both need 3 bonds, you're going to come together and form a triple bond. So it says each nitrogen atom needs 3 electrons to achieve its octet configuration. A triple covalent bond comes about when the atoms share 6 electrons, 3 each. Now the triple bond is extremely strong. Yeah, super, super strong. If you're sharing 6 electrons, yeah, that is a super strong bond. If it's a super strong bond, what we end up with is a compound that is virtually chemically inert. Now, nitrogen gas is used often because it's not flammable. It's very good at like suppressing fires and other kind of chemical things. It doesn't react with stuff, and that's because it's so happy with its triple bond. Why would it do any reaction whatsoever? So after bonding, do all atoms have a full outer shell? Let's just check. 1, 2, 3, 4, 5, 6, 7, 8. Yay, this one is happy. Check this one. 1, 2, 3, 4, 5, 6, 7, 8. Yay, that one is happy. So yes. And that's the end of double and triple bonds.